Whoa! I never thought about that!
Have you ever looked up at the night sky and just wondered, why do stars seem to flicker and dance like that? It's a question people have been asking forever. Well, today, we're going to pull back the curtain on this beautiful illusion and get right into the science of what's really going on.
You know, every good explanation starts with a bit of a mystery, and it turns out there's a really fascinating one hiding in plain sight, right over our heads. Once you start paying close attention, you notice things that don't quite add up.
And here's the biggest clue, something you've probably seen 100 times without even thinking about it. Some lights in the sky, the stars, twinkle, but others, like Mars or Jupiter, they just shine with this constant, steady glow. So what's the deal? Why the difference? Figuring that out is the key to solving this whole thing.
So let's lay it out, plain and simple. On one side, you've got the stars, and they look like they're sparkling. On the other, the planets, just holding a solid, unwavering light. They're both up in the same sky, we're looking at them through the same air, so that tells us something really fundamental has to be different about how their light is getting to us. To crack this puzzle, we have to go back to the source. We need to understand the incredible journey that a little bit of light takes from a star that's trillions of miles away all the way down to your eye.
So let's just quickly get on the same page. What is a star? It's a gigantic ball of super hot gas, kind of like our sun, and it's making its own light. But, and this is the most important part for our story, stars are just unbelievably, mind-bogglingly far away. And that massive distance has a huge consequence. Even though a star is a giant fiery ball, it's so far away that by the time its light gets all the way here to Earth, it's basically a single tiny point of light, like one little focused beam shooting through space. Now remember that, a single point. It's vital. All right, now for part 2 of the puzzle. After that little point of starlight travels across the huge empty vacuum of space, it has one last hurdle to clear before it gets to us, our own atmosphere. See, our atmosphere isn't just some calm, perfect bubble of air. Oh no, it's more like a turbulent, invisible ocean. It's filled with air that's constantly moving, pockets of warm and cool air, and all these different layers of density just swirling around us all the time.
A really good way to picture this is to imagine you're at the bottom of a swimming pool, looking up. The air above us is basically like invisible, shifting waves of water. It's not still, it's always moving and churning, and the starlight has to fight its way through all of that to reach our eyes.
Okay, so we've got our 2 main clues, a tiny single point of light coming from a super distant star, and a messy, turbulent atmosphere that it has to pass through. Now, let's put them together. This is where the magic happens, and we see how that twinkle is born.
The swimming pool analogy makes this crystal clear. Think about a coin sitting at the bottom of a pool. If the water is perfectly still, that coin looks sharp and stable, right? But what happens if you start sloshing the water around? The coin looks like it's wobbling and shimmering all over the place. The coin isn't actually moving, of course. It's the moving water that's distorting your view of it. And that is exactly what's happening in the night sky. Our turbulent atmosphere is the moving water, and that distant star is the coin. That single tiny point of light is getting bounced around and bent on the very last leg of its journey to your eyes.
The science behind this is called refraction. It's just a fancy word for the bending of light when it moves from one thing to another, like from the vacuum of space into our air. So as that starlight zips through all those shifting layers of temperature and density in our atmosphere, its path gets bent over and over and over again in totally random directions. So let's walk through it one more time. First, that single point of starlight hits our atmosphere. Then, all the moving air bends that tiny path of light like crazy, constantly changing its direction. From where we're standing on the ground, this makes the star look like it's jumping around, getting brighter and dimmer and even changing color slightly. And finally, our brain takes in all that rapid-fire shifting and says, hey, look, a twinkle. You know, with any good scientific idea, one of the best ways to know you're right is to check out the exceptions. So what about the things in the sky that don't twinkle? This is where everything really clicks into place.
So why don't planets twinkle? It all comes down to how close they are. Because planets in our solar system are so much closer to us, they don't appear as a single point. Through a telescope, you can see they're actually little disks. So you can think of a planet's light not as one tiny ray, but as a whole bundle of light rays coming at you.
And while our atmosphere might jiggle a few of those individual rays around, the overall picture stays pretty stable. All those little wobbles basically cancel each other out, and we see a steady, solid glow. Which leads us to the ultimate test of this whole theory. If our atmosphere is really what's causing the twinkling, what would happen if you just got rid of it? And here it is, the final, undeniable proof. Astronauts up in orbit, looking at the stars from above our messy atmosphere, see perfectly still, unwavering points of light. Out there, the stars don't twinkle, not even a little bit. Why? Because there's no air to bend their light. And of course, there's an official scientific name for all this: astronomical scintillation. It's the technical term that astronomers, going all the way back to people like Isaac Newton, who first figured this stuff out, use to describe what our atmosphere does to starlight. So here's the big takeaway, the simple and kind of beautiful truth. The stars themselves, they're shining with a constant, steady light. The twinkle we see isn't happening trillions of miles away in deep space. It's happening right here, in the last few miles of light's journey, as it passes through our own planet's restless air. So I'll just leave you with this thought. The next time you're outside at night and you see a twinkling star, remember what you're actually watching. You're not just seeing a distant sun. You are literally seeing the evidence of the invisible, wild, and beautiful dance of Earth's atmosphere.
And that's just one tiny big question. Imagine what's next. Subscribe, and let's keep wondering.